discuss about the performance benchmarking of various message queues, namely Apache Kafka, Apache RabbitMQ, and Redis PubSub. Message queue performance is generally measured by two factors: throughput, which measures the total data in bytes produced and consumed per second; latency, which measures the time taken for a single packet of data to be produced or consumed. High throughput and low latency generally means better performance for the message queue. There are several existing frameworks that's commonly used to measure message queue performances. The first one is Golang Flotilla. Another kind is log-based framework. The last kind is custom proposed frameworks used by researchers. This picture shows a typical framework that is used to measure the performance of various message queues. So first of all, message queue configuration are passed in through command line arguments. This would then call the workload generator, which would call the data reader and driver. Data reader has direct access to the data, which is also the messages that we want to publish to the message queue brokers. The driver would then create producer and consumer. Producer would get messages from data reader and publish it to the broker. Consumer will, on the other hand, listen to the broker and consume the message. There's two kinds of operations that's commonly done here. One type of framework would perform calculation on throughput and latency while receiving and producing at the same time. The other kind will log out key informations and use the logged out data to perform calculation after production and consumption is complete. Here we'll be proposing a new framework to better understand how performance works, how performance measurement can be done for message queues. We'll first start off with throughput. So throughput, we have a producer. The producer, before publishing anything, will log out the start publishing timestamp to the log file. After that, we'll publish message nonstop for 10 seconds. Once the publish action is done, it will log the end publishing timestamp and message count into the log file. With the two timestamp, we'll be able to calculate the time difference. We'll be able to use the message count divided by the time difference and calculate out the average messages that are published per second, which is the throughput of publishing. Now we'll discuss about the throughput of consuming. So we have consumer that's listened to the message queue. So whenever the consumer receives the first message from the message queue, it will log out the start timestamp, which is when the first message is received. It will continue to listen until an end signal or a timeout is received. When that happens, it will log out the time when the last message is received and the total message count. The same operation will be done just as the producer to calculate out the average throughput for consumption. Now I'll be talking about how we propose the framework for latency. So for producer will first generate a unique message with UUID. It will log the publish time of this message with the ID into the log folder. Then it will publish the message to the message queue. Once we get an acknowledge from the message queue, we will log out the acknowledgement time to the log folder. By calculating the time difference between the time where we produce the message and where we acknowledge the message, we'll be able to get a rough idea of how long it takes for the message to be transmitted to the queue, which is the producing latency. Now I'll be talking about the consuming latency. Because most of the message queues consume through a channel-based implementation, it will be impossible for us to calculate the time difference between like what we did with producer, as there's no acknowledgement sent. So we are going to log out the time where we receive each message and calculate the time difference between each message received. That will give us a rough idea of what's the latency of consumption. So now we'll perform testing of the new framework. We run the new framework with publishing and subscribing model. We tested it with Apache Kafka, Apache RabbitMQ, and Redis PubSub. We publish it using a few different modes of PubSub. We first have single producer, single consumer mode. We have single producer, three consumers mode, three producers and the single consumer mode, and lastly, three producers and single consumers mode. Now I'll be discussing about the results of our experiments. So as can be seen here, we will be showing an example of a single producer and single consumer mode production latency, because there's quite a few different experiments that we conducted, which will be impossible for us to show all here. So as you can see here, the latency wise, we will tell that Kafka generally has the best performance, followed by RabbitMQ, followed by Redis PubSub. However, as the number of bytes increase per message, we can tell that the performance generally degrades, and the amount of anomaly points for Kafka tend to grow more significantly than other message queues. The same can be said about consumption rate, which seems to follow exactly what happened with production rate, except for that consumption seems to take a much longer time than production. Now I will be looking at the production throughput for single producer and single consumer. As you can see, Kafka is significantly better than the other two message queues. It's able to hit about 800,000 messages per second, whereas the other two just roughly managed to hit about 100,000. And Redis PubSub performed really bad in this. Like it was only about 10k messages per second. Now let us look at consumption. Consumption rate seems to be the bottleneck with message queue performance. As you can see, when the message is shorter, consumption rate tends to be significantly higher. When message length increases, consumption rate decreases significantly as well. This is especially true with the case of Kafka. So after we have run through all these test framework, we have a few of future works that we think is worth looking at. We think it's better to have a better visualization of anomalies in latencies of messages to understand and explain why these spikes in production and consumption time happens. We also think that by varying the existing message queues configuration will be more important, will be better, and give us better understanding of message queue performance under various conditions. In conclusion, from the performance comparison, we'll be able to come to the following conclusion. Kafka is generally better than RabbitMQ, and RabbitMQ is generally better than Redis PubSub when it comes to performance of message queues. The observation and potential explanations that we are able to get from this experiment. Here are some of the observations that we made. Kafka has the highest number of messages with high latency. Kafka's performance decreased the most when the message size increases. Kafka's performance decreased in multiple consumer mode. Here's some of the explanation for that. The reason why Kafka has the highest number of messages with high latency and why its performance decreased when message size increased is probably because it retains message in memory, whereas the other two message queues would forget about the message once it's been consumed. Kafka's performance decreased in multiple consumer mode is probably because of context switch between consumer groups, whenever there's multiple consumer groups subscribing to the same topic.